In this video, we will look at two examples of solving linear inequalities, and we will also look at how to express our final result in interval notation. Our first inequality is 2x minus 7 is less than or equal to 4. So our first order of business is to isolate the x term. So I'm going to start by adding 7 to both sides of the inequality. So now I have 2x is less than or equal to 11. And my next step is to divide both sides by 2, leaving me with x is less than or equal to 11 halves. It's perfectly fine to leave your answer as a fraction. You can call that 5.5 if you want to. You can say it's 5.5, but x is less than or equal to 11 halves is just fine. But now we want to write our answer in interval notation. Interval notation sometimes comes more naturally after you've graphed the solution set on a number line. So what we want to do first is we want to plot the number 11 halves on a number line. So we said before 11 halves is equivalent to 5.5. So I know that 11 halves would fall between the numbers 5 and 6 on the number line. Now, all my possible x values in the solution set are going to be less than 11 halves or equal to 11 halves. So that means I want to include the number 11 halves in my solution set. So I will show that with a closed circle on the graph. And everything less than that means I shade everything to the left. Now, as I shade to the left, keep in mind I'm going towards negative infinity because I can continue going towards my negative numbers forever. There's no bound or no end. Now, the graph helps me write my interval notation. So I look at the left side of my graph and I see there's a negative infinity. And when I say I look at the left side, I mean I look at the left part of my shaded area. So my shaded area goes all the way to the left towards negative infinity. But on the right part of my shaded area, my rightmost bound is 11 halves. So on the right side of my interval notation, I stop at 11 halves. Now, the infinity symbol always gets a parenthesis, but since I'm including 11 halves in my solution set because it was less than or equal to, the 11 halves gets a bracket in the interval notation. So remember, when you're writing your interval notation, it's always the left side of your shaded area comes first, and then the right side of your shaded area comes second. And then I have my interval notation, negative infinity, comma, 11 halves with a bracket. Let's look at example 2. I have some simplifying and combining like terms to do before I get my final solution. So the left side of my inequality, there's no simplifying necessary. So 5 minus 3x is greater than. Now, on the right side, I want to start by distributing 2. Don't add 11 plus 2. Otherwise, you're not following the right order of operations. We first want to distribute the number 2 because that's multiplication. That has to come first before we add 11. So we get the 2 is going to be distributed. So we get 11 plus 2x plus 14. Now I want to combine the constants 11 and 14. So 5 minus 3x is greater than 25 plus 2x. Now I have variables on both sides, so I want to collect my variable terms on one side of the inequality. Now there's several ways to do this. I'm going to show you the way where I subtract 2x, which means I'm going to collect my x terms on the left-hand side of the inequality. In class, we can look at other ways to do this, or if you have another method, we will look at other ways. But for this video, we're going to collect our variables on the left-hand side. So now on my left, I have the constant 5, and then I combine negative 3x minus 2x, so that gives me minus 5x is greater than 25 because the positive 2x and the negative 2x cancel out. Now I have to isolate the x term on the left, so I have to subtract the constant 5. So be careful though, the x term, the coefficient, the negative 5 goes with the x. So the coefficient is negative 5. So bring down negative 5x, and now that's greater than 20. I'm going to divide by negative 5. Since we have an inequality, division by a negative number should make you remember that we have to reverse this direction of our inequality sign. And the reason why we did that is because we divided by a negative number. So you'll notice at the bottom of your worksheet, there's a little question for you to answer. What do we do when we divide or multiply by a negative number? So make sure you answer that question, and we can discuss it in class if you still have further questions. But our solution is x is less than negative 4. So let's put it on a number line. So let's plot -4. Now, since I'm just less than -4, I'm not including -4. So I denote that by having an open circle on my graph. And then I want to shade everything that is less than -4. That is everything to the left of -4. So again, we're going towards the negative infinity. So for my interval notation, the left side will have negative infinity, the right side will have -4, but now they both get parentheses because -4 is not included. It was just less than -4. So I cannot also be equal to -4. So my interval notation is negative infinity, comma, -4 with a parenthesis. Now, you can always check your solutions to a linear inequality just like if it were an equation. So you can test any value for x that would fall in that interval notation. So basically anything between negative infinity and -4 is fair game to test. So for instance, you could test -5 for x because -5 would be less than -4. If you look on your number line, -5 would be to the left of -4. So when I say test -5, go back into the original inequality and substitute -5 everywhere you saw the x value. And this time, you're not going to look for a balanced equation, but you want to make sure that the left side now becomes greater than the right side. So you get a true inequality statement after you substitute in the value for x that you chose.